Hey guys, Miss McMahon here, and today we're going to evaluate several different trig functions at several different angle measures around the unit circle. We're going to work through this by building the unit circle back up when and where we need it, so that we do not have to rely on any sort of unit circle memorization. I'm not a fan of that because as long as you get to the point where you understand the unit circle and where it comes from, you can always rebuild it at these different places where you need them. So we'll get started on that. We're first going to do that with 5 pi over 6. So to evaluate the sign of 5 pi over 6, we need to first find where 5 pi over 6 is. So if we start with the XY coordinate grid, and we keep in mind that the unit circle is a circle with the center at the origin and a radius of 1, then we can work within our coordinate grid and the circle that we know is there. So we start at the positive x-axis with 0 degrees and 0 radians. And if we go to the negative x-axis, that's 180 degrees, which is pi radians. And that is equal to 6 pi over 6 radians, because the 6 divided by 6 will cancel out to be 1. And what I did here is I made the denominators of these two fractions the same, and I'm going to take the 1 whole pi, which is the top half of the unit circle, and I'm going to think about it in terms of 6 pieces. So I'm actually going to go ahead and break that unit circle up into those 6 pieces, and then we're going to count around the unit circle, which you'll see is an incredibly helpful tool. So we're first going to have 1 pi over 6, and then 2 pi over 6, which reduces down to 1 pi over 3. Then we'll have 3 pi over 6, which reduces down to pi over 2. Then we'll have 4 pi over 6, which reduces down to 2 pi over 3. And then we will have 5 pi over 6, which does not reduce. So what we have here is we have this angle that starts at 0 and goes until 5 pi over 6 is the 5 pi over 6 angle, this angle right here. And what that does is it creates a reference angle or a reference triangle that we're going to put in place right here. And we're going to use that reference triangle to evaluate the sign of 5 pi over 6. So we're going to have theta at the origin. And we have, in this case, theta is equal to 30 degrees. And I know that because 5 pi over 6 is 1 pi over 6 away from 6 pi over 6. So this angle right here is pi over 6. And I know that pi over 6 is 30 degrees. So this angle right here measures 30 degrees. And this is a right triangle. So this last angle here has to be 60 degrees. And that creates one of our special right triangles, which is, again, how the unit circle was built. Now we know that in the unit circle we always have a radius of 1, and the radius is functioning as our hypotenuse right now. And that means that to have a radius of 1 and to have the 30, 60, 90 special right triangle side length patterns, that this long leg across from the 60 degree angle has to be the square root of 3 over 2. And this short leg across from the 30 degree angle has to be 1/2. And the last thing that I need to do is consider the fact that from the origin, I went down the negative x-axis, which means that this is negative root 3 over 2. And then we went up the y-axis, so this is positive 1/2. And these side lengths of the triangle correspond to the coordinate point that we get at 5 pi over 6, where this angle lands on the unit circle is this coordinate point right here because of the lengths of the sides of that triangle. So if we want to evaluate the sine of 5 pi over 6, we're going to look from angle theta, which should always be at the origin, and we won't know that sine is the opposite side divided by the hypotenuse side. So we can do 1/2 divided by 1, which is just 1/2. So we have the sine of 5 pi over 6 is 1/2. With this, because again that unit circle always has that radius of 1, we get the pattern that the sine of an angle is equal to the y coordinate point, or the y value, within the unit circle, because when you divide by that hypotenuse of 1, you get something remains itself. So we could also just look at the y coordinate point that we had at 5 pi over 6 and see that the sine of 5 pi over 6 is 1/2. All right, moving on. Next, we're going to look at the cosine of negative 7 pi over 4. Again, we're going to start at the positive x-axis, and negative 7 pi over 4 is a negative angle, which means we're going to go clockwise to have a negative measured angle. Starting at 0, we're going to do something very similar to solving for the sine of 5 pi over 6. I'm going to consider that 180 degrees is going to get us to negative pi, which is equal to negative 4 pi over 4, because the 4's will divide out and we'll simply be left with negative 1 pi. So thinking about it in terms of 4's, we're going to break the bottom half of the unit circle up into 4's, which means that starting at 0, we'll move down to negative pi over 4, negative 2 pi over 4, which will simplify to negative pi over 2, negative 3 pi over 4, negative 4 pi over 4, and what we have to do is we have to keep going because we haven't reached negative 7 pi over 4 yet. So we're going to keep going another pi over 4, and we would get to negative 5 pi over 4. Then we would get to negative 6 pi over 4, which will reduce down to negative 3 pi over 2. If we go one more pi over 4, that gets us to negative 7 pi over 4. And that's the angle that we want to evaluate, where this angle intersects the unit circle. If we went one more pi over 4, we'd be at negative 8 pi over 4, which would reduce down to negative 2 pi. So what we did is we went through this rotation to get us the angle starting at 0 to get us to the angle of negative 7 pi over 4. And what that does is it creates this reference triangle. Reference angle, reference triangle, and we're going to use that to actually evaluate at the angle. So knowing that the difference between negative 7 pi over 4 and negative 8 pi over 4 is a distance of pi over 4, that is our theta angle, because theta is always at the origin. And I know that pi over 4 is equal to 45 degrees, which is why this is a 45, 45, 90 special right triangle, which means it's isosceles. And I know that if the radius has to be 1, which we know it does in the unit circle, then the side lengths, to stay proportional of the 45, 45, 90 side length pattern, the side lengths have to be the square root of 2 over 2, and the square root of 2 over 2. Which again, the side lengths correspond to the coordinate point where we see this angle intersect with the unit circle. Root 2 over 2, root 2 over 2. So if we're trying to evaluate the cosine of negative 7 pi over 4, we know that that is, from theta, that is the adjacent side divided by the hypotenuse side. And if we take the square root of 2 over 2 and divide it by 1, we get itself. So we will just get the square root of 2 over 2, since dividing by 1 does not change the number. So the cosine of negative 7 pi over 4 is the square root of 2 over 2. This creates this pattern in the unit circle. We saw it in the last angle evaluation, but again, keep in mind that anytime we're in the unit circle, we're dividing by 1. So if we take the adjacent side and divide it by a hypotenuse that is always 1, whenever we're in the unit circle, we're going to get the pattern that the cosine of theta is equal to the x coordinate point, or the side of the triangle that runs along the x-axis. And that pattern can be helpful when you're looking at slightly more complex parts of the unit circle. All right, next we're going to take a look at the tangent of 600 degrees. And we know we start at the starting point on the positive x-axis, and for a positive angle we're going to go counterclockwise. And in this case we will go a full 360 degrees, a full rotation, before reaching our angle. So we're going to keep going. If we go another 90 degrees, we reach 450 degrees. And if we go another 90 degrees, we reach 540 degrees. And then we still need to go another 60 degrees before we reach the angle that we want, which is 600 degrees. This is going to create yet another reference triangle for us. And we know that theta is at the origin. In this case, it's 60 degrees because we had to go 60 degrees past the negative x-axis to get to our 600 degree angle we wanted to find. So that means that this angle here is going to have to be 30 degrees. So then we have another 30, 60, 90 special right triangle, but this time it is oriented differently than the last one that we looked at. The radius, however, is still 1 because we're still working in the unit circle, which means that opposite of the 30 degree side, opposite of the 30 degree angle, we have to have the side 1/2, and opposite of the 60 degree angle, we have to have the side root 3 over 2. And we went down the negative x-axis and the negative y-axis, so both of these side lengths are going to be negative. So that gives us the coordinate point, negative 1/2, negative root 3 over 2, which corresponds perfectly with the side lengths of the triangle we created because that represents the distance we traveled from the origin to the coordinate point that the angle 600 degrees intersects with the unit circle. So the tangent of angle theta we know is opposite over adjacent. So we can set up that division of negative root 3 over 2 divided by negative 1/2. And then we just have to remember how to divide two fractions. A lot of people use the rhyme copy.flop to help remember how to divide two fractions because you copy the first fraction. Dot represents multiplication because this turns into a multiplication problem. And then the flop represents taking the reciprocal of the second fraction or the bottom fraction. And so the reciprocal just means you flip the fraction. So instead of -1/2, it will be -2/1. And then we need to remember how to multiply two fractions. Well, 2 divided by 2 will cancel out to be 1. The negatives will also cancel each other out because dividing two negatives or multiplying two negatives gives you a positive number. And then we just end up with the square root of 3/1, which of course is just the square root of 3. So the tangent of 600 degrees is equal to the square root of 3. In the unit circle, anytime that we have a reference triangle lined up properly in the unit circle or on the XY coordinate grid, we get that the tangent of theta is equal to y divided by x. That's the tangent pattern. So we could take the y coordinate point and divide it by the x coordinate point, which again in the unit circle is the same as the sine of theta divided by the cosine of the angle theta. And so we did that just up here and then simplified to find the tangent of 600 degrees. If you found evaluating that angle in degrees easier than radians, you're not alone. Students are introduced to degree units of an angle much earlier than they're introduced to radian units of an angle. So one thing that I see my students do sometimes to be successful is they take these radian angles and they first convert them to degrees and use that to evaluate the function at whatever angle they're working with. And I think that's great so long as you always finish a problem in whatever unit you were given. So you always have to make sure that at the end of a problem you convert back to whatever unit you were given. But if you're able to be more successful in degrees, then by all means use degrees each and every time. That will make you much stronger at converting back and forth as well. So looking at the sine of -90 degrees, again, a negative angle means we're going to go clockwise, starting at 0 degrees. And -90 degrees is going to get us down to the negative y-axis, where we find ourselves at the coordinate point on the unit circle that is 0, -1. Because we did not go anywhere on the x-axis and we just went down that radius of 1 on the y-axis. So we're at this coordinate point. Now we could remember that the sine of an angle in the unit circle is the y coordinate point, and we could just say that the sine of -90 degrees is -1. If you understand where this pattern comes from, I would encourage you to use it. So we have it as simple as that. The sine of -90 degrees equals -1. What I would add to that is that for people who are more visual, I've seen my students create sort of makeshift triangles, and if this helps you, I say go for it, with the understanding that this triangle that we're about to make cannot actually exist, because what we're going to do is we're going to say, hey, this triangle has an x side of 0, because we actually didn't move anywhere from the origin. And then it has a y-axis side of -1, because we went down 1. And then, of course, it has a radius of 1. So understanding that, put theta in at the origin, understanding that this triangle cannot actually exist, since we can't actually have a side of 0 for a triangle, but using it enough to see that from theta, from angle theta, we have the opposite side is -1 divided by the hypotenuse side, is 1. It gives us a sine value of -1. That might be helpful for people who really want to see that reference triangle, even when we're working with a coordinate point on one of the x or y axes. So hopefully that's helpful to you. And lastly, we will finish up with the tangent of pi over 2. And I know that pi over 2 is equal to 90 degrees. So we start at 0 and we go 90 degrees to get to pi over 2. Or we can think about it as 180 degrees as pi radians. And if we cut that in half, if we divide that by 2, we're going to get the halfway point, which is at the positive y-axis. So we're now at the coordinate point 0, 1. And we want to evaluate the tangent of that angle, the tangent of pi over 2. Now again, we can fall back on the pattern that the tangent of an angle is the y divided by x when the reference triangle is set up properly in the unit circle. So we can do y divided by x. Or again, we can also look at that reference triangle, that imaginary reference triangle that doesn't really exist, but again, if it's helpful to some of you. We have theta at the origin, we have our 90-degree angle. So we have an x side length of 0 because again we never traveled anywhere from the origin on the x-axis, and then we traveled 1 up along the y-axis, and we always have that radius of 1 in the unit circle. And we see that tangent is the opposite divided by the adjacent side. So we get 1 divided by 0. However, we know that we cannot ever divide anything by 0 because it is not possible to take one object and divide it into 0 groups, because it cannot simply just disappear. It has to be somewhere, and there's no way to make one object split up into 0 groups. So what we find is that the tangent of pi over 2 is simply undefined, because we know we cannot divide by 0. So I hope this helped. I hope we've learned how to count around the unit circle to find different angles, as well as how to use reference triangles, reference angles, to evaluate trig functions at those various angles. I'm here to help, so let me know if you have any questions, and thanks guys.